Okay, so I'm going to first show you the output of this project, which I've built on gearsBot. So this is an open source free website, very close to what we do in code.org. So here we can shift from blocks to Python, and from Python back to blocks doesn't happen. So if you start writing in Python, then I think we cannot move back to blocks. But if you have written code on blocks, then you can move to Python. So this is the line follower robot, which is a very simple and interesting project. So I'm gonna simulate the output. So this is the movement of the robot. So here what we are doing is basically there is a light sensor at the bottom of the robot, which is detecting where the line is. So edge of the line. And according to that, it's moving either left or right in a small portion of curve. Okay. So here you can customize your robot. You can also customize the fields. So different worlds are also available. Now let me show it to you what the Python code looks like. So this is the Python code. As you can see, it's quite lengthy. Um, okay, but if you go to the blocks, it's just a simple one, two, three, four, five blocks, 5 to 6 blocks. So here the logic of this is basically we are using it in a loop. So this robot will continue to move as long as there is a line. There is also a way to stop the robot because here if you can see, sorry, simulator. Here you can see after a while the line is still there, and yet uh, the platform ends. So after the robot comes here, it falls off the edge. So there is a way to stop that as well. For that we are going to use another sensor. So I still haven't studied all the sensors that are here. For now I'm using only the light sensor to be able to identify the edge. So this was just a trial and error. Let me explain what the code looks like. So color sensors, light sensitivity or intensity basically has to be tracked. So as you can see, there is a black line on the screen. Okay, here it's a black line and the platform is white. So the white light reflection and the black light reflection. So when we want to identify the edge of the line, we are putting it at 50. So basically the sensor which is at the port 1 of the robot is situated exactly at the center when I write 50. Okay. Now what is greater than 50? So basically whenever the light intensity is greater than 50, then I see the left edge. Let me show it to you. Where is the annotation tool? Yeah, here it is. So if you can see, if my robot is situated at the center of the line, then if the light intensity is more on the left, then the curvature is basically towards the left. And if it is more on the right, then the curvature is on the left. So this was more like a trial and error for me to figure out how it really works. Okay, so let me come back to the code. Yeah. So if the light intensity is greater than 50, then basically I want the tank to move left. So this is left and right is basically motors. Okay. So every robot has two wheels, or it could be four as well. So it depends upon the position. So if these are the two motors, okay, then one moves clockwise and the other moves anti-clockwise. Then also, if one moves with the speed of 20 and the other is stationary, then the robot is moving anti-clockwise. If this is 20 and if this is 40, then both the wheels will move, but it will incline more towards the right hand side. So here to move left I have chosen 20 and 0, and to be able to move right I have chosen 0 and 20. So that's the code for this.